In this question, number 3, the first number 3, a skier is skiing down a slope, inclined at an angle. So this is question 3. And the angle is 25 degrees to the horizontal. There's friction, so I'm not sure. It seems a bit steep. I'm not sure if we've covered any of these with friction before. So let's draw it quite carefully. 25 degrees. The skier is skiing down with friction involved. So what are the forces acting on this person? There's the force of gravity down, we know this. There's the normal force acting up, and there is friction acting along the slope. Okay, so this is a situation where the object, the skier in this case, is actually not traveling horizontally. She's accelerating down the slope, so we're going to rotate the axes so that the x-axis is like this and the y-axis looks like this. Okay, the y-axis is like this. And we'll keep our traditional down the slope is positive, this is negative, this will be positive, this will be negative. So that's our diagram. And again, we're going to have to find the components of the force. We've done this before. We have an x component here, and we have a y component parallel to the y-axis. So maybe my x looks more like this. Okay? And so let's figure it out. What the question is asking is how long? How long? And not how long a length, but how long a time it will take her. So if we're looking for delta t, we know that we're going to have to deal with kinematics. So let's see what we are dealing with, v naught, v, and a. As soon as I see that kinematic information, I write down my given because I want to know what I'm dealing with. It says, how long will it take her to travel 45 meters down the slope? So I know the delta x is 45 meters if she starts from rest. And that's all they tell us. We need 3 pieces of information to find something here. And they say, how long will it take her? So this is my question mark. So we have to decide, do we want to know her final velocity or do we want to know her acceleration? By now I hope you know that this is our thing that we're going to try to figure out so that if we can use the dynamic information to find this kinematic information, this can be my don't know, don't care, and then I can find the time they're asking us for. So let's look at the dynamics of this problem. And we'll look at it from, first of all, we'll investigate it along the slope because we know she's accelerating down the slope, right? And it's asking us this question. So looking at it along the slope, remember, don't try to do all the directions at once. Pick a dimension. In this case, we're picking the x dimension, and we're going to analyze it this way. And we're going to do our MA equals the sum of the forces. So MA equals, well, what are the forces acting in the y direction? We have the x component of g, FG, x, and we in the positive x direction, and in the negative x direction, we have the force of friction, right? So we have here that she's 60 kilograms. So 60A is equal to, now what's the expression for FGX? Well, it's going to be FG. Now you decide. It can either be cosine of 90 minus 25 or sine of 25. I kind of like to make it sine of 25. But just to be explicit here, if this angle is 25, this angle becomes 25, looking at these triangles. 25, and then this angle becomes, is that 75, 25, 70, 65, 75 degrees in order to make that 90. If that doesn't make sense to you, you can if it makes sense to you, fast forward a little bit. I'm going to make this really explicit. I'm going to just draw this all out. So for example, we've got our actual force of gravity, right? We've got our slope, which looks like this. Our slope is like this. Here's our force of gravity. And now I'm going to draw in my x and my y components. So my y component And then, oh sorry, then I'm also going to draw in my y-axis, which is this one. So this is x, and this is y, right? And so if I wanted to look at it like that, I can see that this y component is going to be parallel to the y-axis, and my x component is going to be right here. So this is my x component. So FGX, FGY. This is 25 degrees. 65, not 75. So if this is 25 degrees, looking at this triangle, I can see that this has to be 65, right? And then looking at this this is a right angle, this is a right angle. So then that means this angle is again 25. That angle in there is 25. So just to solve this triangle, if this is FG, the pink one is the hypotenuse, I can see that FGX is equal to FG, and it can either be the cosine of 65, or I could say FG sine of 25. Since I'm given the 25, that's what I'm just going to use. So we've got FG sine 25. So 60 equals FG sine 25 minus, now the force of friction, all we know about is the mu. So I'm going to put mu Fn in here, right? All right, so what else do we know? Well, we have an expression for Fg. I can make this a little more drawn out. I can say 60A equals 60 times 9.8 sine 25 minus, now the mu is 0.15 Fn. Okay, so now I'm stuck. Fn. I don't know what Fn is. So I can't actually solve this because my unknown is A. I need to know Fn in order to solve this. So we don't have to worry too much. All we have to do is go to the y-axis and start looking at perpendicular to the slope. Okay, so perpendicular slope, I know that A equals 0. How do I know that? Because the skier's not jumping off the slope, she's not smashing into the slope, she's staying along the slope. So MA equals the sum of the forces, 0 equals, now what are the forces in the y direction? Well, in the positive y direction we have Fn, and in the negative y direction, so subtract FGY. So we can see from this that Fn is going to equal Fg, and then you can see it's going to be cos 25. Go back to the same triangle and see that the y component is either going to be sine of 65 or cos of 25. So plugging all this in, 60 times 9.8 times cosine of 25, you can plug that in. And I'm going to do that now without actually solving this. You can actually get the number, but I'm just going to plug it right back into that equation. So back into that equation, we have 60A equals 60 times 9.8 times sine of 25 minus 0.15 times 60 times 9.8 times cosine 25. And that's my whole expression. Now if I just divide everything by 60, I get the answer. If you've been paying attention, you're going to see that there's a 60 here, there's a 60 in this term, there's a 60 in this term. So you can see that we can cancel out those terms. So this is my expression for A. A equals 9.8 times sine 25 minus 0.15 times 9.8 times cosine of 25. And you do all that math and you end up, oh, I didn't give an answer. So the answer is 9.8 times sine 25 minus 0.15 times 9.8 times cos 25. And we get 2.809 meters per second squared. We're not done yet. We're running out of space, but we're not done because now what we're going to do is plug that into here, 2.809, right, meters per second squared. So now I have my don't know, don't care is the final velocity. T is my unknown. I'm actually just going to erase this triangle. You can always flip back and look at it, and I'll put my answer right here. So without v, I've got delta x equals VO delta t plus 1/2 a delta t squared. It starts at rest. So a is just equal to 2 delta x over 2 delta x over delta t squared. So we end up, sorry, not a, we want delta t is my unknown. So delta t equals 2 delta x over a, and then we take the square root of all that. So square root of 2 times 45 divided by 2.809. Doing that math, we get 2 times 45 divided by, and then square root, and we get 5.66 seconds. I'm off the board. Here we go. 5.66 seconds. Somebody check my work and talk to me if I made a mistake. I occasionally do that.